Hey, Math 1, we are finally to the last section of Chapter 6. And the last section is not actually dealing with systems of equations. It's dealing with something you probably don't have a lot of experience with, something called literal equations. And we are going to solve literal equations in this last section. And these notes primarily deal with examples. And I've got lots of examples because there are lots of different situations I want to help you make sure you understand how to deal with. So it's like each individual example that will be important to understand here. All right, here we go. So, all right, we want to learn how to solve literal equations for one of their variables. And I note that right here, we are going to learn how to solve literal equations for one of its variables. A literal equation, sometimes called a formula, is simply an equation that has multiple variables in it. Like, you guys know some formulas, like volume equals length times width times height. That is a literal equation. It's also a formula. All right. The first thing I want to point out here is this is not that hard to do, although there's some tricky situations. I want to compare this to solving a normal algebraic equation versus a literal equation. So I start with something like this. X plus 5 equals 7. And over here, maybe I have something like x plus p equals q. So on the left, I have an algebraic equation, a typical one, very easy to solve. And on the right, I have a literal equation. And my point here is you solve them the same way, right? The goal is the same in either case. Isolate the variable that you're trying to solve for. Get the variable by itself. Over here, I would subtract 5 from both sides to solve for x. And the same thing over here, except I'd be subtracting p from both sides. And in both cases, I have gotten the x by itself. It's just the answer that looks different. On the left side over here, I can actually subtract 7 minus 5, and I get 2. But here I cannot actually subtract q minus p. Those are not like terms. So my answer is just going to be x equals q minus p. All right? My answer is still a literal equation. It's just isolated the variable that I want by itself. This is what x is equal to. All right, and I could do one more of those, I suppose. Let's compare 2x equals 10 to px equals m. All right, to get rid of something, you do the opposite operation, right? So if I want to get rid of the 2, I divide both sides by 2 because the 2 is multiplied by the x. Well, the same thing over here. If I want to get rid of the p, since the p is multiplied by the x, I do the opposite of multiplying. I divide by p. And p divided by p is 1. And I get 1x, or just x. There's my answer, right? All right, so the point I'm trying to make is this is very similar to solving a regular equation. You're just dealing with variables, but there are some tricky situations. Now in this group, not so much tricky. One tricky thing I think, maybe, or one thing I want to point out. I probably shouldn't have done these first two examples. They're basically like the ones I just did. If I want to solve for h, I need to get rid of the j. And since the j is multiplied by the h, I will be dividing by it. And I simply get m over j, right? Or in the second one here, I want to solve for the a, so I need to get rid of the f. the f has been added, so I'm going to do the opposite. I'm going to subtract f from both sides, and I get m minus f. Now, I'm a little nervous about this, but here's the thing, you guys. You do not necessarily need to show me this. And I will show you what I mean by that as I keep going. But you could probably just go from this step down to this step without showing your work. I'll be able to tell what you did. All right, number 3 here is the first thing I want to make sure you understand. Now, I am solving for p. Now, you might think distributing the p is the way to go, but it's not. You know, if I distributed the p, I'd have PA plus PB. But I don't want to distribute the p. I want to get the p by itself. So I'm actually kind of happy that it's isolated by itself, kind of. And the p has been multiplied by this quantity, a plus b. So if your variable has been multiplied by a quantity, it's okay to divide by a quantity. Divide by a quantity. Please write that down. So in this case, you would be dividing both sides by a plus b. And that literally cancels out the a plus b. And you get p equals c over a plus b, right? All right, that's the first thing I want to make sure you understand. This one, number 4, is similar. The a that we are trying to solve for has been multiplied by 2 things. Well, you can divide by both of them at the same time. I can divide both sides by 3q. And that cancels out the 3 and the q. And it gives me d minus 4h over 3q. All right, and last up, in number 5, my b that I'm trying to solve for has been divided by a quantity. So since my b has been divided by a quantity, I'm going to multiply both sides by the quantity that the b has been divided by, d plus p squared. So that might look like this. I'd be multiplying this side by d plus p squared, and I'd be multiplying this side by d plus p squared. And over here, it would just cancel out, right? It would cross cancel, and I would just get the b. Now on the left side, you don't actually have to multiply it together. You could just leave it as g times d plus p squared. Or if you really want to distribute it, you could distribute it. But either answer is fine, and if you don't have to do the extra work, there's no need to. All right, but the big thing we've learned here maybe is multiplying both sides by a quantity or dividing both sides by a quantity. We're going to see that again shortly. All right, on the back, the examples are tougher. And again, I've put each one on here for a specific reason, so I hope you'll follow along. Up at the top here, I've given you some general guidelines. And that is, this one is important. Gather any terms that has your variable, and by your variable, I mean one you are solving for. The one you're solving for. You want to gather those together on one side of the problem. All right? Any term that's got your variable in it, move it to one side of the problem. And move any terms without your variable to the other side of the problem. Now, we already saw this on the front. undo any operations to get the variable by itself. I skipped this for a minute. I'm going to come back to it. Here is a big one. When your variable is in the denominator, you will have to multiply by it to get it out of the denominator. I'll show you an example of that. And last up, do not have any fractions or decimals within fractions in your final answer. And I will show you what I mean by that. Okay? So here we go. This first one. Notice in this first example, there are two terms that both have an A in it that I'm trying to solve for. And I can't combine them because they're not like terms. So this brings me back to this first thing. If there is more than one term, you will need to factor, or you guys would probably be better if I said the word undistribute. Let me show you what I mean by that. So I need to isolate that A, and to isolate that A, I undistribute it. You guys are all familiar with the distributive property. The distributive property would be if I took the A and I multiplied it times the M and I multiplied it times the T, right? And that would give me this, what I started with. A times M would be MA, and A times T would be TA. So I'm actually working backwards here. Instead of distributing, I'm undistributing. Undistribute, I can't spell, undistribute the A. Since both terms have the A in it, I can kind of remove it. I can undistribute it. That is actually called factoring, which you will learn a lot about next year. I will factor out the A. And this still equals Q, right? Oh, let me go back to green. I have messed that up badly. Okay, so it still equals Q. Now, the A has been multiplied by a quantity. And so I can divide both sides by that quantity. That would look like this, and cancel it out. And I get A equals Q over M minus T. Right? All right, so in that example, we learned to undistribute. Now, that's the last time I'm going to show my work. At this point, I want you to see that you can just think about what you're going to do and show your next line. All right, in this next example, my variable that I'm solving for is in the denominator of the fraction. So when your variable is in the denominator, you know you're going to have to multiply by it. Now, this one's actually a special case because this is an example of a proportion. And we know how to solve a proportion, right? You diagonally multiply. So I'm actually going to do F times Q equals R times G. And there, no more variable in the denominator. And now I can get the F by itself by dividing by Q, right? So out here I'm going to write divide by Q. But I'm not actually going to show it the way I did over here. I'm just going to do it. Dividing by Q cancels out the Q, and then this side would be divided by Q, and there's my answer. F equals R times G all over Q. This is what I mean by you don't have to show that you're dividing by Q. Just do it and write down what you get. All right, example 3. Now, example 3 is going to point out this right here. Do not have any fractions or decimals. So look, I am solving for A, and my A has been multiplied by 1/4. I'm going to do this over here. One thing I could do is I could divide both sides by 1/4 because my variable has been multiplied by 1/4. And this would be a perfectly legitimate answer. Oops, there we go. And Delta Math would take this as the answer, but I will not take this as the answer if I'm asking you to completely simplify this. So please learn how to do it without having a fraction within a bigger fraction. Dividing by a fraction really means multiplying by its reciprocal. So instead of dividing by 1/4, I would rather you multiply by 4/1, or just 4. Multiply both sides by 4. Then you get 4b, and 4 times 1/4 is just 1. It cancels out, and you have AF. There, see, now I don't have a fraction within a fraction. And now all I have to do is divide by, what am I dividing? I'm getting A, divide by F. So dividing by F will get rid of the F, and over here I will divide by F, and there's my answer. Again, see how I didn't show my work so much. All right, example 4 has an exponent on it. So the lesson here is, before you can do the exponent, you have to isolate the exponent. Then get rid of it. So everything else here is the same, but I wanted to point out how to get rid of the exponent. First, isolate the exponent. So in this, the first thing I'm going to do is I want to get the a by itself. So first I'm going to get rid of the g. I'm going to add g to both sides. So on this side, I'll have 5h³ plus g, right? Because I'm adding g. And that'll cancel out the g over here, and I'll have ba². Now I want to get rid of the b. So how am I going to get rid of the b? I'm going to divide both sides by b, right? So over here, that will cancel out the b. And over here, I have to divide both sides by the b. See how I've done that, right? And then finally, last up, I want to get rid of the exponent. So how do you get rid of an exponent? By taking a root. If the a has been squared, the opposite of squaring it is the square root. Taking the square root of both sides is what gets rid of the exponent. The square root and the square cancel each other out, leaving the a by itself. And this is what you get. You get the square root of 5h³ plus g all over b. All right, last two, you guys. Okay, so this is an example of this one. Oops, let me change colors real quick. Gather any terms that have your variable on one side of the problem. All right, so I'm solving for a, and there's an a in this term, and there's an a in this term. So I'm going to take this term and move it over there by adding ba to both sides. If I add ba to both sides, then 9 will be by itself. And on this side, I'll have q² plus ba, right? Because I added ba to both sides, even though I didn't want to show it, I did. There you go. All right. Now, notice that a is in two different terms, right? So how do I isolate it when it's in two different terms? I have to undistribute the a. So that would look like this: a times q² plus b. I'm removing the thing they have in common. I undistribute the thing they have in common. Still equal to 9. And finally, I can get the a by itself because the a has been multiplied by this quantity. So now I'm going to divide by q² plus b. That'll cancel that out. And over here, the 9 will be divided by q squared plus b. And there's my final answer. All right, last one. This is kind of a tricky one because, again, the variable I'm solving for is in the denominator of the fraction. So I know that I'm going to have to multiply by it to get it out of there. But the first thing I'm going to do is get rid of this f. I'm going to add f to both sides so that I kind of isolate the fraction. This would be m to the third plus f. And now I'm going to multiply both sides by a. So that might look like this. Multiply that side by a and multiply that side by a. And the a's cancel out, giving me the b by itself. That's not exactly what I wanted, but watch this. Over here, I'm not actually going to multiply it. I could, but it would take you an extra step. I'm just going to leave it as a times m to the third plus f. Remember, my goal is to get the a by itself. And if I distributed the a, then I'd have to undistribute it to isolate it again. But in this case, you can see that the a has been multiplied by this quantity. So I can divide both sides by that quantity. And that leaves me with a equals b over m cubed plus f. And I have gotten the a by itself. All right, I'm sorry, I think that was a little lengthy, but I thought those were all good examples for you to see. It's the last homework of the chapter. I will see you guys later.